All right, hey, I wanted to do a quick review of like 8 problems that are going to be similar to what you're going to see on the test. So those of you that have the test on Monday, please make sure you watch this video. This will help you greatly, and then you can always email us if you have additional questions. So if we go too fast for sake of time, I want to keep the video as short as possible. You can pause and rewind if we go too fast together here. All right, so here, we're just going to solve. So 8 and 9 on your review. So number 8, we're going to solve using factoring. We have 3 terms. So we're going to factor. Well, a is equal to 1 or greater than 1, so we need to multiply. So using the Moyes method, we're going to multiply that 3 to both sides and write what we have left over. So x squared minus 7x minus 30. So 10 times that 3 is 30, and this equals 0. Set up your 2 sets of parentheses. So we need 2 numbers that multiply to a negative 30, but add to a negative 7. So that would be a negative 10 and a positive 3. So negative 10 times 3, negative 30, negative 10 plus 3, negative 7. Remember, your larger of your factors between 3 and 10, 10 is larger, has to carry that middle sign. This is equal to 0. Well, we multiplied by 3 in the beginning, so our equation is off balance. So to undo that, to get it back to balance, we need to divide each constant by that 3. Because we're solving, then we're going to, and this can't reduce, we're going to add this 10 over 3 to the other side. So here, x is going to equal a positive 10 over 3. That's, boom, our answer. Over here, 3 over 3 is 1. And so because that reduces to 1, here we know that x is going to be the opposite. So it's going to be a negative 1 instead of a positive 1. So meaning if we were to graph this, this would cross at 10 over 3, which is 3 1/3, and at negative 1. And so using the Moyes method, once you get your fractions, you can just take the opposite sign, and that would be your answer after you reduce. So like here, we reduced first, then took the opposite sign. For number 9, if you were to plug this into your calculator, you would see that it's an inequality symbol, so less than or equal to, meaning it can be on the line, and it can be everything underneath the line. So it's all of this. We're trying to say, hey, where's our graph underneath, less than, underneath that x-axis, or equal to that x-axis. And so what we would do is we could write this in interval notation and say, hey, it's going to be underneath this x-axis everywhere from negative 10 all the way to positive 8. And so how we would write that would be a bracket, because it can equal negative 10, and then all the way to positive 8 with, again, another bracket, because it can equal that. If you wanted to write as an inequality, you could. You don't have to. But you would say negative 10 is less than or equal to x is less than or equal to 8. And remember that this symbol here is always going to match that when you're talking about your x variable being in between. So we're saying all of our x values that make this graph underneath the x-axis are going to be between negative 10 and 8. Make sure you use the equal to symbol. Now, simplify. Number 15. So we have 4 plus 3i, and we're subtracting. So be careful with the subtraction problems. Really, if you want to distribute to just make that a little bit easier, then really what we're saying is 4 plus 3i, and then minus that negative times a negative. All it does is flip the sign, so it becomes positive 2. Negative times that positive becomes a negative 4i. And then really now we just have to combine like terms. So we have this 3i and a negative 4i. Well, that's going to give me a negative I. We have this positive 4 and a positive 2. Well, that's going to give me a positive 6. So our final answer is 6 minus I. Now you do want the I to be at the end. Normally we have our variables first, but because I stands for imaginary, we want that to be at the end. Also, remember, you can use your calculator to plug that in, and it'll give you your answer for you. In the same way here, you could use your calculator. You'd have to use parentheses in the numerator, and then parentheses in the denominator, and you would just hit math, enter, enter. If you don't have a calculator, then you would have to remember to multiply by this complex conjugate, which just means it's the opposite sign. So instead of 9 minus 4i, this is going to be 9 plus 4i. And whatever I do to the top, I have to also do to the bottom. And you would have to distribute all of this, and so negative 7 times the 9 gives me a negative 63. Negative 7 times positive 4i would be a negative 28i. 6i times 9 would be 54. So this would be a positive 54i. And then 6i times that 4i would be a 24 positive. So positive 24I squared. Now we've talked about the calculator a few times. I squared, remember, is -1. So really this is saying, what is 24 times -1? Because I squared is -1. Oh, that's a -24. So we get this -63. Combining our two like terms here, we're going to get a positive 26, so plus 26I
Good morning.
minus
If we,
24.
meaning Susan and I, contact
Just kidding.
Grace and your
All right, so then we have even more like terms we get to combine. Pure joy. -63 and -24 would be a -87 plus this 26I. That is just our numerator. That is just the top of this fraction. We found that we had this shortcut here when we are multiplying a complex number to its complex conjugate. And that shortcut was we just take a squared plus b squared. A, in this case, is 9, so 9 squared is 81, plus b is the number attached to I, so it's 4. Well, 4 squared is 16. And then finally, all we have to do is reduce 81 plus 16. And that'll be true every time. And so we get this -87 plus 26I, and this is all over 97. So again, you can put this in your calculator, this divided by this, in parentheses, math enter, enter, and you would get -87 over 97 plus 26I over 97. That would be a lot easier than going through and multiplying by the complex conjugate. But if you don't have a calculator, you're going to have to do it by hand. And I know I went through that fast, but you can pause and rewind and slow me down and listen to my magical voice. All right, solving by square roots. So when we're taking the square root of something or solving by square roots, usually we're going to have two terms. And so when I see these two terms, I just need to get everything away from x squared. So I'm going to add 32 to both sides. And when I do that, I'm left with 9x squared equals 32. How I get rid of the 9 is by dividing. So I'm going to divide both sides by 9. So I have x squared equals 32 over 9 doesn't reduce. But when I take the square root of both sides, I get that x equals plus or minus. Anytime I take the square root, I have to take plus or minus. 32, that breaks down to be 2 times 16. Well, I know that 4 times 4 is 16, and even though those aren't prime, they're a pair. They match. So really, because they match, I have a group of 4s that I can take out. I have a 2 left over that has no friends, so it has to stay inside the radical. So this is plus or minus this 4 radical 2 all over the square root of 9, which is 3. So there are my two answers. And we knew we were going to have two answers because in the very beginning we had an x squared. Well, my two answers come from that plus or minus, one positive, one negative. So you will have to know how to break down a square root. And then remember, if you have a square root that has a negative underneath, so if this would have been the square root of a negative 32, then this would be 4i radical 2. So the negative, all that means is that you take the I out. All right, what about completing the square? So this was that list of 5 steps that you should have written down. So completing the square, we need to move c to the other side. So how I do that is by adding 7 to both sides, and we're going to leave a space. So I have 2x squared plus 8x. I'm leaving my space, and this equals 7. Now, this is that part where we look to see if a is greater than 1, and it is. So we need to divide each term by a. And so when I do that, these reduce or simplify, and I get x squared plus a 4x, leave that space, equals, I need to leave this as a fraction, 7 over 2. Don't write 3.5, please. Just leave it as 7 over 2, and we'll deal with that here in a moment. Now, I need to take half of my b term. Well, half of 4 is 2. Half of my b, and square it. Remember that number here, that square, is my reminder to square this term. Well, 2 squared is 4. And whatever I add to one side, I need to also add to the other side. And so then I need to reduce this. In your calculator, 7 over 2 plus 4, and if you hit math, enter, enter, you should get 15 over 2. So this is 15 over 2. And again, if I'm going too fast, you have the ability to pause and rewind a little bit. Now we just need to solve like normal. So take half of our b term, positive 2. Square that. Whatever I do to one side, I have to do the other. Combine any like terms. So we're just combining this 7 over 2 plus 4. I get 15 over 2. So math enter, 15 over 2. How do I undo a square? Well, take the square root. So when I do that, I get x plus 2 plus or equals plus or minus. Anytime I take the square root, have to do plus or minus. The square root of 15 doesn't break down. 3 times 5, those are both prime numbers. So I'm just going to leave this as the square root of 15 over the square root of 2. And then finally, subtract that 2 to both sides. And so I get x equals this negative 2 has to go out in front, plus or minus the square root of 15 over the square root of 2. And this would be our answer. And so we can just leave it. Now, if you can reduce the radical like we could with 32, then reduce it. Here with 15, it's just 3 times 5. They don't have any pairs, so they both have to stay home. They both have to stay under the radical. All right, 2 more. So number 35 on your worksheet, we're going to deal with the quadratic formula. So here's the quadratic formula. You do need to know that. Here's number 35. A is 3, number attached to x squared. B is negative 5, the number attached to x. And then C, the constant, the number by itself, is 3 in this case. So when I plug this into the quadratic formula, this is the opposite of b. Well, b is already a negative 5, so the opposite of that is a positive 5, plus or minus this John Mundo square root of b squared. So this is negative 5 squared minus 4, because that's part of the formula, times a, which is 3, and times c, which is also 3. And this whole thing is over 2 times a, which again is 3. So what we talked about as a good strategy is just simplify what's underneath that square root first. So we have 5 plus or minus the square root of something, and this is all over 6, 2 times 3. So in your calculator, use parentheses, negative 5, parentheses squared, minus 4, parentheses 3, and we get 25 minus 36, so that should be a negative 11. Now, we've talked about the discriminant. Remember, the discriminant is just the number you get under the radical, right? The b squared minus 4ac, right here. If our discriminant is negative, then the nature of the roots means we're going to have 0 real solutions, meaning it's not going to cross the x-axis when you graph, and we're going to have 2 imaginary solutions, so you do need to know that. If the discriminant is 0, that's where you have 1 solution, and that's called a double root. It bounces off the x-axis. If that number, the discriminant, is a positive number, any positive number, then you're going to have 2 real solutions, and it's going to cross the graph at 2 different spots, just like this one did. So here, our discriminant is a negative 11, meaning we have 2 imaginary solutions, so no real solutions. And we can leave it like this, but I do want you to get used to writing this as 2 separate fractions. So we're going to say 5 over 6 plus or minus, because of that negative under the radical, I'm going to take an I out and bring it in front. So I times the square root of 11, and this is also over 6. And so here are our 2 answers, and that's what you would write on the test. So 5 over 6, so split the fraction out, plus or minus. Because of that negative under the radical, we're going to take an I out, and then just leave it as square root of 11 over 6, because 11 cannot break down, so we can't reduce that fraction. Finally, write an equation. So given our 2 solutions, x equals 3, to go backwards, remember, if our solution is 3, then that means its factor is x minus 3, right? Remember how the factor and the solution, they just carry the opposite sign? In the same way, if the solution was x equals a negative 1/2, then its factor was x plus 1/2. And if that's true, remember with the Moy's method, we take that denominator and bring that out in front. And so really what we have is we have x minus 3 times 2x plus 1. And from here, we would just distribute. So x times this 2x is going to give me a 2x squared. X times a 1 is just a positive x. Negative 3 times 2x is negative 6x. Negative 3 times 1 would be a negative 3. Combine any like terms. So we get 2x squared minus 5x minus 3. And this is equal to 0 because we did solve it. We took the solutions and we found what the original quadratic would be. Okay, I know that was very fast. There's one more thing I want to talk about, and that's if you were given a coordinate plane. So given we have some coordinate plane here, and I gave you a point at 2, comma 3, okay? And this was point A, but this was the imaginary plane. Well, instead of writing 2, comma 3, you would have to write it as 2 plus 3i. So again, don't make that more complicated than it is. The x value is just a real number, so that'd be 2. The y value in this case, you're just going to add an I to the end. So let's do another one. Let's say I said, hey, we have point B here, and it's negative 3, comma, negative 1. So if we had negative 3, negative 1 right here, and I said, hey, this is point B, what are the coordinates of point B? Well, we know negative 3, negative 1, but it's left 3 on the real, so negative 3, but down 1, so minus this 1i. Okay, so anytime you see that, just think of it as negative 3, comma, negative 1, but just don't have the comma there, and just attach an I to the end. Now that was a very quick review of your packet, of the most important things that you'll need to know for the test, but please study all of it, work on all of it. If you have questions, email me, and we'll go over specific questions together.